How do we show that a formula is true? It's not as straightforward, unfortunately, as showing that a formula is false. Most of the time, plugging in numbers won't earn credit. I can't stress this enough. Most of the time, I mean, almost all the time, for showing a formula is true, don't plug in numbers. That's not going to earn credit. Why not? Recall that we just said that a true formula must be true for all combinations of plugging in numbers. So if you're just going to plug in numbers, you'll be plugging in numbers all day. So even after an infinite number of times of plugging in, there'll still be another combination of numbers that you haven't checked. So there must be some other way to show that a formula is true. Something that doesn't involve plugging in numbers. The thing that's not as straightforward is each true formula is justified in its own way. We have to discover each new truth in its own way. Now, if a formula has a plus sign in it, we better understand what plus means. And if a formula has a times sign, we better understand what times means. If a formula has a fraction, we better understand what a fraction really is, and so on. So let's talk about a way of interpreting addition. This is a geometric interpretation. X plus y represents a stick of length x glued to a stick of length y. Now, in the picture we're about to show, there's a small gap between the two sticks just so that we can see what's going on. So for example, 3 plus 5, take a stick of length 3 and glue it to a stick of length 5. Now, there's a little gap here, but if we remove the gap between these two sticks, then you'd have a stick of length 8. Okay, just to clarify, for geometric interpretation of addition, I would ask that you don't just say a single word, sticks. That's sometimes what students want to go with. Try saying at a minimum 2 words, gluing sticks. Even better would be saying something like gluing sticks end to end. Now, I know that's not even in what I had up here, but one end of the stick is glued to another end. A phrase like this is more helpful, and you can do this. You can use more than a single word to describe what's going on, because what's going on here does require more than one word. Let's take a moment to talk about a geometric interpretation of multiplication. X times y represents the area of a rectangle with height x and width y. So for example, you have 3 times 5. There's a rectangle whose height is 3 and whose width is 5. The area of this rectangle is 15. So why is a plus b equal to b plus a true? Well, there's a plus here, and we're not going to plug in numbers at all. We're not plugging in for a or for b. Let's apply this geometric interpretation of addition. So a plus b, as a picture, is here's a stick of length a, and then we're going to glue that or attach it, tie it on to a stick of length b. And I just drew a and b as different lengths. B is, at least in the picture, sort of being represented by a bigger number because the stick is a little longer. But then the right side over here is b plus a, so b should come first. B is on the left, and this same stick, I tried to draw a stick whose length was exactly the same as we saw in the previous diagram, because b should be still the same b from the other side, and then a is next. And if we glue here and we glue there, we ought to end up with this long a plus b stick and then this long b plus a stick. Those are the same length. Now, in the answer that's provided above, b happens to be bigger than a. You could provide a different answer that would be accepted that has a bigger than b. In both pictures, in this picture up here and in this picture down here, the a stick is the same length, and in both pictures, the b stick is the same length. And it's easier to see that the a plus b picture and the b plus a picture are the same length by placing one diagram directly below the other. So here's this, and then just because it's easier to spot the length of the sticks by doing this, directly underneath is where the beginning of this stick is drawn. And plugging in numbers will not be considered for credit. Sometimes people want to write something like 3 plus 8 equals 8 plus 3 as the answer to this question, and it won't earn points because that just, yeah, sure, both sides here simplify to 11, but that just shows why this formula would be true just for those numbers. What if you substitute 3 again for A, but 9 for B? So we need some argument that's not going to involve specific numbers, and so here's a generic argument that's going to do that up here. Okay, we're not quite done with the day's material or even for this part, but try these. And then you can click to get a key. So why is a times b equal to b times a true? Why is a plus 0 equal a true? Why is a plus quantity b plus c equal to quantity a plus b plus c true? Give these all a try on your own, and then click on these links to see how things went.